Welcome to myprojectbazaar.com. Now let me discuss about implementation of a high efficiency, high lifetime and low cost converter for an autonomous photovoltaic water pumping system. In this paper, we propose a new converter for providing the high voltage without the use of any chemical elements such as batteries and etc. The converter is designed to drive a three-phase induction motor directly from the photovoltaic energy. The use of three-phase induction motor presents a better solution to a chemical DC motor water pumping system. Our developed system is oriented to achieve a more efficiency, more reliable and maintenance-free and cheaper solution to a standard ones to a users. The developed system is based on the current felt multi-resonant converter. Here we are using a multi-resonant converter to boost up the input voltage. The resonant converter is also known as resonant to inductor boost converter, as well as full bridge three-phase voltage sourcing inverter. The basic topology of this system, the high voltage gain and low input current ripple from this proposed system. In this paper, further we will improve the use of noise isolated recovery snubber algorithm along with a hysteresis controller and the use of an consonant duty cycle control to improve its efficiency. In our system is expected to have a high lifetime due to inexistence of an electrolyte capacitance and the total cost of a converter is very low. The system is promising solutions to be used in the isolated locations and to deliver to a very poor communities. This is the flow diagram of our module. First, we have to give the input voltage like photovoltaic or any other. But now here we are giving the DC input voltage. That means whatever you are giving the input voltage, that is the low input voltage. Then the input voltage is passed through the switches. In the switches, by using a pulse generator, it will provide some signals to a MOSFET switches. In the MOSFET switches, the signals are passed through a load. In this load, here the three-phase inverter is used and the DC-DC converter also perform in this place. After converting the DC to DC converter, the three-phase inductor will provide the feedback current and again goes to a switch control, and switch controls the output signal and again come back to the switches and pulse generator, and finally it going to boost DC converter. It will boost up the input voltage into a high voltage. By using the three-phase inverter, the input voltage will boost up by using the three-phase inverter. That means resonant to inductor boost converter, because here we are using this resonant inductor boost converter only we are using, so the outputs are high efficiency and high reliability output. In the boost up DC converter, the voltage double rectifiers are used, so the output voltage will be high from compared to the input voltage. Now let me see about the module of our project. In our module there are three sections. First is the input section, and is a DC conversion, and another step is a inverter, and finally the input voltage is boost up to a high output voltage. In the input voltage we are giving a normal DC input voltage. Whatever input voltage you will give, it is no problem. So I'm giving a 100 voltage DC voltage. Then the input DC voltage is passed through a DC to DC converter section. In the DC to DC to converter section, the current fed inverter and the resonant tank will convert the input DC voltage into another DC converter. It will converting the DC to DC voltages, and it's passed through the three-phase inverter. In this inverter, it will boost up the input voltage. That means a high DC voltage bus will pass through the input DC voltage to a three-phase inverter. In this inverter, inverts the input voltage to the output. By using of this section, the DC to DC converter and three-phase inverter, the input voltage is finally converted into high output voltage. Totally we getting about some 160 voltage. The input voltage is 100 but we getting 160 voltage in the output. So there is a high efficiency and a high voltage we getting by using this system. In this system, by using a resonant inverter, in that section the voltage is passed through the voltage doubler rectifier section. In this rectifier, it will boost up and it will double by the input voltage to the output voltage. So we getting the high voltage when compared to the input voltage. In our section, we are using a MOSFET switches. It is used to control the switches using a pulse generator, and finally we getting a output from a voltage doubler circuit. So finally, when compared to an existing method, our method is a better high efficiency and a high output voltage. So thank you.